what are units? According to the dictionary, a unit is any measurement that there is one of. What kind of units are there? Well, there are many different systems of units, but the most commonly used are SI units, CGS units, Imperial units, and natural units. Let's start off with SI units first. Where does that word come from? Well, it comes from the French system International d'Unité, also known as International System of Units. There are a total of 7 base SI units. All physical quantities have units which can be built from these 7 base units. So it is possible to create a different set of units by defining a different set of base units. For a better understanding, look at the table on the next slide. The table you see here is called the 7 base units, and it tells you the name and symbol you use when measuring a certain base quantity. For example, if you were to measure the length of a curtain, you would need to use a unit meters, also known as m. In order to measure the mass of an object, you will need to use the unit kilograms, or kg, and to measure the time, you will need to use a unit second, or s, and so on. These base units are like the 26 letters of the alphabet for English. Many different words can be formed by using these letters. Now let's move on to the CGS units. In the CGS system, everything is the same as the SI system, except for the fact that the meter is replaced by the centimeter and kilogram is replaced by the gram. This may be a simple change, but it means that all units derived from these two are also changed. For example, the units of force and force here are different. These units are used most often in astrophysics and atomic physics. Next is imperial units. Imperial units arose when kings and queens decided the measures that were to be used in the land. All the imperial base units, except for the fact of time, are different to those of SI units. These units are used by the Americans and in some places by the British. Some examples are pounds, miles, gallons, and yards. However, you need to know that the imperial system units are based on antiquated things like the length of the king's foot and the size of a barley corn. So the relationships between units can be quite random. Natural units. Natural units are the most sophisticated choice of units. Natural units are physical units of measurement based only on universal physical constants. Here the most fundamental discovered quantities, such as speed of light, c, and elementary charge, E, are set equal to 1. This system of units is used in high-energy physics and quantum mechanics. Now it is time to learn how to change units. It is very important that you are aware that different systems of units exist. Furthermore, you must be able to convert between units. So if you want to change millimeter to meter, you divide by 1,000, or if you want to change kilometer to millimeter, you multiply by 1,000, as shown in the graph. The same method can be used to change milliliter to liter or kiloliter. If you want to change millimeter to meter, you divide by 1,000, or if you want to change kilometer to millimeter, you multiply by 1,000. Or you can use the King Henry slider. In this slider, the letters included are K, H, D, B, C, N. It is also known as King Henry died by drinking chocolate milk. K stands for the unit prefix kilo, H stands for hecto, D stands for deca, B stands for base or starting point, another D for deci, C for centi, and M for milli. A unit prefix that has the same name as the one in the graph means it belongs in that group. So kilometer will be in the kilo group, hectometer will be in the hecto group, and so forth. So how do you use it? Put your finger on the unit that you are starting from, also known as the base, hop left or right to the unit that you want to convert to, count the number of hops, and move the decimal point in the original number to the number of spaces to the left or right. A reminder, when moving to the left or to the right, you would need to multiply or divide by 10 for each hop. Here's an example. I want to convert 27.4 grams into milligrams, so I need to start with my finger on grams, or the base. I hop 3 times to the right to get to milligrams, so I need to move the decimal point in 27.4 3 spaces to the right, which now becomes 27,400 milligrams. This is the same as multiplying 27.4 by 1,000, so 27.4 grams is the same as 27,400 grams. So why are units important? Without units, much of our work as scientists will be meaningless. We need to express our thoughts clearly in units to give meaning to the numbers we measure and calculate. Depending on which units we use, the numbers are different. For example, if you have 12 water, that literally means nothing. There is no specification of what unit you are using. You could have 12 milliliters of water, 12 liters of water, or even 12 bottles of water. As you can see, units are an essential part of the language we use. And that concludes the unit lesson.